I work on artificial intelligence. Now, if they say that, many people think about something like this. I do image processing, something cool stuff. Or gaming. We heard already about the chess game. Or something like robotics, cool stuff, really these tools. Or even autonomous cars driving them by themselves. But then I say, sorry, I work on text analytics, and this will come to your mind. Boring, stupid text. Now, I've been doing this for 10 years, doing research and doing it in business, and I want to share a little bit with you my experience and why I'm still fascinated in this text, and what we can do with it. And I will try to compress 10 years into 15 minutes, which is not so easy, so bear with me if I spend some more seconds at the end. Text analytics is like a good magician. It has a lot of tricks behind, and it looks like magic, but it isn't. And I want to explain a little bit about you where the tricks are and why it is cool, and why it is impressive at the front, but behind it's basically counting. So if you can count 1, 2, 3, 4, then you can do many things in text analytics, and it's not really surprising how it works. So let's go back in time, 10 years. 10 years ago, 2008, the iPhone just came out. People started working on the internet with the iPhone. Google was 10 years old, so you were able to search websites and stuff like that. And I was in a small company here in Zurich, and we did rocket science. We called it at that time business intelligence, or sometimes later web monitoring. And it was really rocket science. When we gave to some company and explained what we do, they said, "Oh, this is great, you can do that? Well, that's impressive." And what we did was, we counted words on the internet. So we just collected all websites that contained the word Coca-Cola and Pepsi and Red Bull, and then we counted how many websites we found and plotted a chart like that, and that was wow. Okay. Before I explain why it was wow, what is the use? Well, you can use it in marketing. Before, you had to do a survey and ask people, what do you think about my brand and how popular is it? And now you could go to the web and ask, well, you can count it on the fly in real time. Now, why was it rocket science? Because it's not so easy as it sounds. I mean, if I say we just count Coca-Cola, at first we need to find out what are the proper websites. And then in the website, we need to find out what is the content that we are going to look at. If you look at a website like this, oh, sorry, wrong button. Like this, well, you have the main text here, which is a small text here, and around you have all this clutter information which you are not really interested in. You have images, you have advertisements, you have links to other web pages, and if you want to see where Coca-Cola or Pepsi-Cola is mentioned, well, you probably want to concentrate on this text. Now, if you have the text, the next thing is you need to find out in which language it is. Because you want to apply these language tools that we have, and they are language specific. Now, language detection is quite easy, yeah? Take some common English words, I, you, then, he, it, and this gives you the language. And then people write on the internet whatever they want, so they write something like, I can speak just English und Deutsch. Cool, that's mixed language. And there are many people who really write like that because they are grown up with many languages in the term, or they mix English terms into German text because it's a Fachterminal and stuff like that. And once you have the language determined, you want to split up the large text into smaller chunks, like sentences or words, because you cannot deal with 10 pages of text in one chunk, and you want to have smaller parts. So you split up the sentences by the dot at the end, right? Yes, that works perfectly. Not always. And then you need to split the sentences into words. And you can think about what is a word or a token, and there are many issues as well to find the proper boundary of words. And then, once you have done that, you have these texts, and you want to find out, is it about my brand? Now, Coca-Cola is a cool brand, that's why I took it as an example. There are other brands in Switzerland which are not so easy, like salt. Yes. it's not only the spice, but it's also Salt Lake City, or the movie, Salt, with Angelina Jolie. So you need to do some disambiguation to figure out what you're talking about. Okay, but at that time, we kind of came up with ideas how to solve it. And then a revolution occurred. And this revolution was Facebook and Twitter. They started in 2004, 2006, but by 2010 they were really famous. There were something like 500 million Facebook users and stuff like that. And our customers became more intrigued in, well, we don't want to have just word counts. We want to know more about what people are saying about our brands. And one topic that came up very often was sentiment analysis. And that's quite easy. You want to know whether the brand is in a positive or negative context. Because, well, it's different for a company. I mean, if you count only Pepsi, well, yes, but if somebody says Pepsi is great, that's better than Pepsi is not my taste, or something like that. So we needed to figure out sentiment. And yeah, you can do that. You can also count. You just count something like positive and negative words, and it's easy. But as I said, it was on Facebook and Twitter. Well, Facebook is still okay, but Twitter makes it pretty hard. So I brought you 3 examples, and this is, well, it's a little bit cherry-picking, but try to figure out the sentiment of these 3 sentences. Tim Tebow may be available. Wow, Jerry, what the heck are you waiting for? Or is this one of your little jokes, like Elvis playing at the Marquee next Tuesday? Or you can date me if you still sag your pants super hard. That shit is played the fuck out. Now you're laughing. We were supposed to find out what the sentiment of these is. Yes. I mean, yes. And people expected us to have a good sentiment accuracy. So we asked people, humans, to label this by hand. Well, okay. The first one is positive, because they want to buy the ticket, obviously. The second one seems to be ridiculous, negative. And if you can figure out the third one, just let me know. I don't have any clue. So, but then, well, this was kind of solved at some time, and we spent some time in research on that as well. I moved to university in between, and I want to make a jump now, a time jump, to 2018, because in between we solved a lot of problems, and they're really in a way solved by now. So, as I said, text classification. Well, this is solved. And text classification means we can find out positive, negative, but we can also find out something like the age and gender of the author. Okay, scary. If you write something like 200 lines of text, we can guess your age and your gender and from which country you come from, even if you write in English. We could figure out which companies and locations were mentioned, even if we didn't have a closed list of the companies. We could just say, oh, in this part of the text there is a company mentioned. We could figure out and classify which topics are there. So just automatic topic generation. We could even do something like a very simple question answering system. I will talk about that later on. And machine translation, well, we didn't do it, but Google did a good job. Well, a relatively good job in 2005, 2010. And very recently there is a new system, I don't know if you know it, DeepL, which is excellent in translating, and it's kind of solved now. But then, about 3 years ago, people came up with new demands. And the new demand for text analytics was dialogue systems. Now, dialogue systems, what is it? The question is, I want to talk to my computer and I expect it to understand what I'm saying and give me a reasonable answer. And if I talk on and go on, then after some time I want to have a good discussion with my computer. Not laughing, that's really what they're wanting. So, the first breakthrough was already in 2011, and that was IBM Watson. It was a huge machine trained for one particular purpose, and that is to win the game show Jeopardy! So there was a game, and it competed against humans in understanding reasonable natural language tasks. And I didn't bring the task here, but what they did is, usually, or what we are doing in question answering, there is a particular question, who was Swiss president in 2015, and then the answer is Simonetta Sommaruga. And behind it, there's a lot of technology. So what we have at the left-hand side is, if you really want to talk, you need to translate your spoken language into text. That's cool for English and German. It's not so cool for Swiss German because there is not much translation from spoken Swiss German and all these different dialects. Makes it difficult. But once you have text, you need to find out what is the person talking about. What is the intent? What does he or she want? Then next step is you need to find out what is the entity you're talking about. So if we look at this again, I want to know who. So I want to have a person, and the entity would be the Swiss president in 2015, and I want to connect it and find out what is the output that matches these both entities. And if I have more than one utterance and reply, then I need to have something like context tracking. Because if I spoke about a video or a movie, and then I ask who is the director, I expect the system to know that I spoke about a movie and I'm looking for the movie of this the director of this movie. And on the other hand, well, we need to create a reply, so we need to select which answer, and we need to fill in the slots because we expect a reasonable reply in natural language. And then we need to put it again into spoken language, speech to text. In a way, for simple dialogue questions like who is the author of this book, this is solved by now. We need a database with all the data behind, but then the next step came. We want to chat with our computer. And this is not a purposeful chat, but we want to chit-chat about weather or sports or politics or whatever. Okay, so we want to talk to the computer really. It's not question answering anymore. It's like, hi, I'm Tom, what's your name? Tom, how are you? Great, and so on. People really want to do that. Maybe not here in Switzerland, but there are robots already in Japan where you can chat with your computer, and it's sold to people who live alone to make them a social companion. So, what kind of conversational systems were there already? Let's look a little bit back in time. The first system was already implemented in 1966 by Joseph Weizsäcker, a philosopher, who in the first wave of artificial intelligence said, well, we can talk to your computer. And he implemented something like a psychoanalysis. And what he did was very simple. He took a sentence that the user input, like, I have an issue with my father, and then it made a question from that, why do you have an issue with your father? And people said, oh, because he doesn't give me the car. And then it answered, oh, that's bad, why? And it went on and on and on, and without understanding anything, people stood for up to 2 hours in front of the system, typing in their personal details, and in the end, when he wanted to publish it, they said, well, you cannot publish it, it's too personal. So it was really successful at that time. 30 years later, internet was there, so people could do the same on the internet, and Cleverbot is one of the most famous systems for this. You can type in any expression, any sentence you want, and the bot tries to convince you that it is a human and answers like a human, and that you cannot distinguish it from any reply. It has already run something like 150 million dialogues, and it's really convincing. So you can really say anything and it comes a reasonable reply back. Then 4 years ago now, they built this HitchBot. And HitchBot was a cool idea. They put the technology of the Cleverbot behind and put it on the street and said, this bot should travel from Halifax to Vancouver. And it should really hitchhike. So people could take it, set it into their car, and then talk to them while riding, and at the end say, oh, you have to drop you here and try to get another hike. It arrived after a couple of weeks, and then they did the same in the United States, and it was trashed after a couple of days. And that was really big. And then 2 years ago, they brought out the Amazon Echo Dot, where you can just ask Alexa, oh, what is the height of the Eiffel Tower? And it says something like 320 meters or something like that. Okay. But all these systems are basically still question-reply systems, very simple, nothing very involved, and they are rule-based. So there is a lot of rules behind and human engineering. What we are now working on in research is how to generate text from scratch. And this is a totally different idea. And I want to just briefly try to describe it. What we take is a huge amount of sentences, texts, arbitrary texts, like flipped classroom is a teaching method. And we give the computer this text character by character. And it learns if there is an F, then in this sentence there is an L as an character. And then FL is followed by I, FLI is followed by P, and so on until he learns the entire sentence. And then we give it another sentence and another sentence. And it learns like, well, sometimes after an F there is this L, E, I, P, P, E, and then there is an R in the sentence, or here it's a D. So it learns all these combinations of characters and following characters. Okay, and we do that for billions of sentences. And now we can reverse it and say, well, start with an F and generate the next character that is most likely. And the next character that is most likely. And surprisingly, this doesn't output rubbish, but this outputs something like Shakespeare. So this is trained on Shakespeare novels and texts, and if you read it, oh, if you were a feeble sight, the courtesy of your law, your sight and several breath will wear the gods, and so on. If you don't understand it, don't be annoyed. This is rubbish text. It's just a sequence of characters without any meaning, but I would be sure if you put it on a stage, people will think it will be Shakespeare. And you can do the same for Wikipedia articles, scientific articles, source code, MIDI files, you can generate music. And then, well, this is still rubbish text. What can we do with it? We want to have dialogue systems. So we trained it on dialogues, movie subtitle dialogues. And then something strange happens. It outputs reasonable replies. So if you say something like, hello, hi, how are you? I'm fine. Or what's the color of the sky? It's blue. Okay, honestly, this is cherry picking. It sometimes says also yellow or red, but it says a color. So it understands in a way that this is asking for a color and outputs a color reasonably. But still, there is no way to determine what it will say. I can ask a question, I can make conversation, but there's no way to know what it does. And this is what we are currently working on in many people in the world, in research and NLP, natural language processing, to have meaningful outputs. And the idea is, we give it information, for example, about a restaurant, and then it should generate something like, the Mill is a cheap fast food pub located in the city center near Café Cieliebak. Now this doesn't look any impressive anymore, right? I mean, this is almost a sentence which is here. The cool stuff is, this is generated character by character. Yeah, so the computer only needs this and thousands of examples of restaurant reviews to generate it from scratch. You can apply it to any technology, anything where you have a database and data about a certain fact, and then generate the corresponding text. Okay, so now I'm through, and I want to finish with something which I found very inspiring. We've asked our computer, what are you? He's not sure yet. And then we asked the most important question, do you plan on taking over the world? No, I don't. Thank you very much.